Hey Fairchild, Ryan here. I am now currently standing near a river near my house. But I'm wondering, how did this get here? So as you can see, this stream here is located right in the middle of the woods. There's not a lot of things around, but you could also see by the landform, right here, slants up a little bit. And on the other side of the river, it slants up. So, how did that happen? So here we see a section of the river that's kind of like a lip, you see? And how I believe this got here, just like, since water flows down naturally and it carries stuff with it, that this lip was created by water. Another thing to support this is all the rocks and sediment over here. As you can see, up here, it's only like dirt, twigs, and that's just like a stone pillar from an old stone wall, because this used to be farmland. But you could see like all sediment in here and things that wouldn't normally be on dry land. Now, as you know, erosion relates to fluid dynamics, because erosion is caused by the flowing of water, which is what a fluid is. But what else you could do with fluid dynamics and natural water streams is test if there was possibly a pollution outbreak, where the pollution would end up. As you see here, I have a white piece of paper. What I'm going to do with this is I'm going to tear a little piece off, put it in the water, and test where it goes, as to kind of mimic an outbreak of a pollution. But do not worry, I will not leave the paper in the water. This place is rarely touched by people. There's no trash whatsoever. So I will make sure to gather the paper. So I'll just think this piece of paper is our pollutant, and that rock is a factory. So you can measure kind of how far the pollutants will go. Let's pretend this here to here is our river. And this is like, let's say, like a very, very small, this is a very, very small scale. This is just an example of someone might do. There's many more complex ways to do this, but this is just a simple way, just to show people how it's kind of done. So they would test with non-toxic stuff. They would test it from where the river is, and they would watch it and monitor it as it went down the river and how long it took. So they could calculate from where that started and where it's going now, how long that paper took to get to the destination right there. So what we could do with this is take pollutants, possible pollutants, track where they could go, so we could stop them if anything happens. This is another thing that has to do with the flowing of a fluid. So since the fluids naturally flow, I've already said that before, but the pollutant that we had, we could test how this pollutant could flow down the river, and we could stop it before it actually hurts any animals. Fluid dynamics is a very important role in this, because fluid dynamics will help people identify. There's equations they could use to see where a river will flow. So you could use that equation to test pollutants too. Or you could look at a river, and just by knowing the basics of fluid dynamics, you can know, oh, water flows, and water could carry stuff with it. So that's how we know that water can erode. There's been tests, there's been observations, there's been a lot of things. So fluid dynamics is behind all of it. So this overall video has just been a basic understanding of fluid dynamics and natural water flow. But there are many other things. There's equations, there's other ways you could test pollution and see how stuff has eroded. But I hope you found something out of this video, and thank you for watching.